Okay, now we have evaluate 1 upon x minus 1 into x minus 2. Okay, so we go for simple practice. So we have 1 upon whatever the thing is nothing but a upon x minus 1 plus b upon x minus 2, which will be eventually, hence 1 will turn out to be a into x minus 2 plus b into x minus 1. You take to make x a0, put x is equal to 2. So eventually you get 1 is equal to, this becomes 0, 2 into 1, b. So b is 1. Then to make b0, put x as 1. So you get what? 1 is equal to a into 1 minus 2 minus a plus b into 0. So therefore a is equal to minus 1. So eventually it's going to be integral of minus 1 upon x minus 1 dx plus 1 upon x minus 2 dx, which will be log x minus 2 minus log x minus 1, which will be log x minus 2 upon x minus 1 plus c. So it's eventually option number A, log x minus 2 upon x minus 1 plus c. Okay. Furthermore, we have 6x plus 4. Okay. We have integral of 6x plus 4 upon x minus 2 into x minus 3 dx, which is going to be, so 6x plus 4 is going to be a upon x minus 2 plus b upon x minus 3, hence a into x minus 3 plus b into x minus 2. As usual, take x as 3. If you take x as 3, you get 6 3s are 18 plus 4, 22. 3 minus 3, 0. And 3 minus. So b is turning out to be 22. Suppose you take x as 2, so that the b part becomes 0. And you get 6 2s are 12 plus 4, 16 is equal to 2 minus 3 minus a. So a would be minus 16. So it's eventually minus 16 into 1 upon x minus 2 dx plus 22 into 1 upon b x minus 3 dx, which will be eventually 22 log x minus 3 minus 16 log x minus 2 plus k. 22 log x minus 3 minus 16 log x minus 2 plus k. That is option number C. 22 log x minus 3 minus 16 log x minus 2 plus k. It's option number C. Okay. Now we have another example by the method of partial fraction. Now here, this one, if you factorize this by quadratic formula, you end up getting this as 3x upon x minus 2 into x minus 1. So again, this is going to be nothing but a upon x minus 2 plus b upon x minus 1. So that means 3x is equal to a into x minus 1 plus b into x minus 2. So suppose x is equal to, say, 2, so that this part becomes 0. You'll end up getting 6 is equal to a. So a is 6. Suppose x is equal to 1, so that this part becomes 0. You'll end up getting 3 into 1. 3 is equal to minus b. So that is b is equal to minus 3. So ultimately, it's going to be integral of 6 x minus 2 dx minus 3 integral of 1 upon, this is x minus 2 into x plus 1. We had a mistake over here. is going to be plus 1. So our whole answer, suppose x is minus 2. X is minus 2, so you end up getting minus 6. Okay, we need to do x is minus 2, so you end up getting minus 6 is equal to minus 3a. So a turns out to be 2. So it's 2. And then suppose x is equal to a into x. Again we have done it. It should be x plus 1 into x minus 2. So we need to take x as 2 only. Sorry, we made a mistake here. X as 2, and hence we get 6 is equal to a into 2 plus 1, 3, b into 0, that is b. So hence a will turn out to be 2 itself. And suppose x turns out to be, we want now minus 1. In that case, minus 3 is equal to minus 3b. So b will turn out to be 1. So a is 2 and b is 1. Yes, so it's going to be 1 upon x plus 1 dx. So it's going to be 2 log x minus 2 plus log x plus 1 plus k. So it's going to be 2 log x minus 2 plus log x plus 1 plus k. I hope we got it done. Yes, x minus 2 into x plus 1 will turn out to be, of course. So we took x as, yes, x we took it as a 2. So 2 minus 2, 0, 2 plus 1, 3a is 6. Okay, so a is 2. Then we took x is minus 1, so minus 3b. So b is 1. So it's 2 log x minus 2 plus log x plus 1 plus k. So among these, this is the right option. Okay. Now, before we started partial integration or partial fractions, I mentioned you may even have cases where the denominator, in this case, examples that we did till now, the denominators had 2 factors, each of degree 1. Both of them are linear variables. So total degree of the denominator is 2. But you may have cases wherein the denominator may have something which has got degree 3, say x minus 1 into x minus 2 cube. So the degree is totally 3. In that case, the process of taking x as 1, x as 2 may not work. We'll have to do a different process altogether. So here we have 4x dx upon x plus 1 into x plus 3, the whole square. Now how do we go about doing this? Now here if we see the denominator has a degree 1 plus 2, 3. So that means this is going to be a upon x plus 3 the whole square plus b upon x plus 1. This alone will not be enough. There has to be, possibly there could be a third one having x plus 3 too. Why we take that? It's possible. Suppose it's not there, the c part would become 0. That's it. As simple as that. So hence we have to consider the 3 possibilities. That is a upon x plus 3 the whole square. Now if you take LCM of this whole thing is x plus 3 the whole square into x plus 1 into x plus 3. And here you have a into x plus 1 plus b into x plus 3 the whole square plus c, which is just x plus 3 the whole square into x plus 1, c into x plus 3 into x plus 1. This should have been just x plus 3 the whole square into x plus 1. This means 4x's. So if you simplify this can be written as 0x square plus 4x plus 0. Now here the process of putting x is equal to minus 3 plus 3 will not work because there is a square term over here. So we need to expand this. So it's eventually ax plus, we'll put all the constant terms a Then here you have bx square. So there will be one bx square here plus 6bx. So that is going to be 6bx plus 9b. The 9b part will go here. And if you expand this, you get one cx square. So we have cx square. And then 3 plus 1, 4cx. So that should be coming here 4cx plus 9, 3 into 1, 3 into c. So you have 9b plus a, and here you have plus 3c. Now these three will go together, these two will go together, and these three will go together. Now if you compare, if you see b plus c, you have to equate with 0. See, compare the x square terms and the x square term. This is 0x square, this is b plus c into 0. So we get b plus c is equal to 0. You can call this as equation 1. And here a plus 6b plus 4c. That is a plus 6b plus 4c will be equal to 4. This is equation number 2. And the last one, we have 3c plus 9b plus a, that is also equal to 0. Now if you see in this one, you can either multiply or subtract, or you can do substitution. You get b is equal to minus c. This value of b we can substitute over here, and hence you get 6b minus 4b. So a will turn out to be 6b minus 4b. So a plus 2b is equal to 4. So a can be taken as 4 minus 2b. A will be 4 minus 2b. So we can substitute in this equation, and you get 4 minus 2b is a plus 9b. Instead of 3c, we can write minus 3b is 0. So it's eventually 9b minus 5b. That is 4b is equal to 4. So b will turn out to be 1. So here we do the process. You can use this principle in the previous one, the simple partial fraction, but that is something which we cannot use here because there are hidden expressions over here. So putting x is equal to minus 1, if you do, two of the terms will become 0, and you'll end up getting b is equal to 0, which could create a wrong, get you a wrong answer, and the approach will be absolutely wrong. Now since b is equal to minus 1, c has to be minus 1, b is equal to 1 because b is equal to minus c. Hence a has to be 4 minus 2b, that is 4 minus 2, 2. So it's going to be a is 2. So ultimately it's going to be 2 upon x plus 3 the whole square dx plus b, that is 1 upon x plus 1, plus c, that is minus 1 upon x plus 3 dx. This will be eventually 2 into x plus 3 the whole raised to minus 2. So it's going to be minus 2 upon x plus 3, because it's going to be minus 1, x plus 3 raised to minus 2, its n is minus 2, so it's going to be x plus 3 raised to minus 2 plus 1 upon minus 2 plus 1. So it's going to be this, and this is going to be log x plus 1 minus log x plus 3. So it's eventually minus 2 upon x plus 3 plus log x plus 1 upon x plus 3 plus k. So this is how we get as the answer, minus 2 upon x plus 3. Thus, we can use square partial functions to get this. Let's see what we have next. Okay, here we are using method of partial fractions. Evaluate x plus 5 dx. Okay. So we have x plus 5 dx. So it's going to be a upon x plus 2 the whole square plus b upon x plus 1 plus c upon x plus 2, right? So this is, hence LCM is going to be x plus 2 the whole square into x plus 1. So it's going to be a into x plus 1 plus b into x plus 2 the whole square plus c into x plus 1, 2 into x plus 1. And this thing is nothing but x plus 5. So you have something 0x square plus x plus 5 is equal to this thing. So now let's see, we have an x square term here, so it's going to be, there is one x term. So it is b plus c into x square. If you see, there is one a term here, there is one a, here there will be one 4bx plus 4b, and the last one will have 2 plus 1 3x plus 3c into x, plus again here you will have the last term is going to be a of this, and there is one 4b a, and then there is one 4b, and then there is one 2c, and hence you will have b plus c is equal to 0, which means c is equal to minus b, a plus 4b plus 3c, and here you have a plus 4b plus 2c. a plus 4b plus 3c is nothing but 1. a plus 4b plus 2c is 5. We can even subtract 3 because the coefficients are the same. So if you subtract 2 minus 3, 2 minus 3, if you do, you get 3c minus 2c is c. C turns out to be minus 4. If c is minus 4, b would be plus 4. And hence, now we can find the value of a in this. Substitute a plus 4b. a plus 4 into 4, 16 minus 12. So, space is the problem here. Okay. So, after this, you substitute in equation number 1 a plus 4b. 4 4s are 16 and 3c. Minus 3 into minus 4 minus 12 is equal to 1. So it's eventually a is equal to minus 3. So a is minus 3. So eventually you get minus 3 upon x plus 2 the whole square. And b is 4 plus 4 upon x plus 1. c is minus 4 minus 4 upon x plus 2. We have to take the dx of this. So it's eventually, this will now become minus 3 and x plus 2 raised to minus 2 is minus 2 plus 1. So it will become x plus 2 raised to minus 1. This is as x plus 2 upon minus 1. Minus 2 plus 1 minus 1. Plus 4 log x plus 1 minus 4 log x plus 2 plus k. So it's eventually 3 upon x plus 2 plus 4 log x plus 1 minus 4 log x plus 2 plus k. So this is going to be our answer. So among these you have definitely not this a 4 log x plus 1 minus 4 log x plus 2 plus 3 upon x plus 2 plus k. So it's option number A that works to be. Obviously there is a bracket over here, 3 upon x plus 2 plus k. Right? So this is, we do square fractions and see, yes, that's the option we have here. Fine. So this is their simple examples on partial fractions which are based on basic concepts of mathematics as told earlier. If it was a simple partial fraction where the denominator was of the form x plus a into x plus b. You can take a into x plus b into x minus a, put x as minus a, x as minus b, and find the value of a and b. But if you're having the denominator in the form x plus a into x plus b the whole square, there is a possibility of a third fraction. Possibility. Now, if you say there is no possibility, the c value could become 0 or the b value could become 0. So accordingly, it would exchange and adjust itself. But we have to take that into account. So you take it as a upon x plus a the whole square plus b upon x plus b, and c will be just equal to c upon x plus a. And then if you take the LCM and then open the brackets and compare the coefficient of the x square terms, compare the coefficient of the x terms, compare the coefficient of the constant terms, you get 3 equations with 3 variables. Do by subtraction, addition, and find the value of a, b, and c.